My name is Sanju Kumari. I am here to present my progress monitoring presentation. The title of my presentation is Big Data Analytics for Demand Response in Smart Grid. I am working under the supervision of Dr. Neeraj Kumar. And these are my objectives. So first one is to study different techniques of big data analytics for demand response management in smart grid domain. The second one is to design algorithms for reducing the storage space of data using big data analytics and process this data for demand response management. Third one is to design algorithm using data deduplication for efficient demand response management. And at last, to verify and validate the proposed algorithm. And I have completed 15% work since last progress monitoring. And there are various big data analytics I have studied. So to achieve the objective, two various big data analytics techniques have been studied. Classification tree analysis, support vector machine, recurrent neural network, and long short-term memory, which is a type of recurrent neural network. Recurrent neural network is nothing but it's an artificial neural network which works as like human brain. And further, LSDM will be used for demand response management in the smart grid. Now, I want to define what is classification tree analysis. So, classification tree analysis, here classification is a form of data analysis that extract models which defines important data classes. Second one, it extracts models which is called classifier and predict categorical discrete values which belongs to a specific finite set of categories or classes. Third one is tree means a graphical structure which displays hierarchical tree with a root value and subtrees of children with a parent represented as a set of nodes. And analysis means the careful examination of the data. This is the block diagram representation where at first I load the data, then data pre-processing is going on, and then we extract the features, and we select important features and use the CTA algorithm. And next one, I worked on entity, and final result I got. Decision tree classifier is a most important part in classification tree analysis. So I have done my work in this through these examples. Now, I want to define what is recurrent neural network and long short-term memory. So, recurrent neural network is an artificial neural network where the output from previous step are fed as input to the current step. Here, all input or output are independent on each other since it provides current feedback to the neural network, so it is called RNN. LSDM is a type of RNN where long-term memory refers weight value and short-term memory refers value of cell state from one layer to the next layer. And there are three gates are found in RNN. Which one is forget gate, input gate, and output gate, which to control and to protect the cell state. Gate means nothing but it's information is going through the gate. Whatever information I want to keep, so I can keep it, and another one we will stop. There is some limitations of RNN that the long-term dependency, so to avoid this, this LSTM is used. Now, general architecture and equation of RNN. So, in this equation, ST equal to FW into HT minus 1 comma XT. So, here HT is new state, FW is some function with parameter, and HT minus 1 is old state, and XT is an input vector at some time step. Now, when we open RNN, the chain-like nature reveals that recurrent neural networks are closely related to sequences and lists. They are natural architecture of neural network to use for such data. Now, LSDM is a chunk of RNN which has loops. So it works through loops. Loop allows information to be passed from one step of the network to the next. Here X is the input and H is output. LSTM is a very special type of recurrent neural network which works various tasks which is much better than standard version. It was discovered by Horkheimer and Escamillo in 1977. Sometimes we only need to look at recent information to perform the present task. For example, consider a power prediction model trying to predict the next record which is based on previous ones. It has capability to add or remove the information to the cell state which are regulated by structure is called gate. Gates are a way to optionally let information through. Initially, I have discussed this one. They are composed with sigmoid neural network layer and point-wise multiplication. Some steps of LSTM algorithm by which it works in power prediction model. The first step in our LSTM is to decide what information we are going to throw away from cell state. Next one is this decision is made by sigmoid layer called the forget layer. It looks at ht-1 which is previous layer and xt input vector at some time step and outputs a number between 0 and 1 for each number in the cell state ct-1. ct-1 is nothing but previous cell state. 1 represents completely keep this and while 0 represents completely get rid of this. Now second one, let's go back to our example of a power prediction model. We are trying to predict the next record based on all the previous ones. In such a problem, the cell state might include the gender of the present record and so that correct record can be used. When we see a new record, we want to forget the gender of old record. The next step is to decide what information we are going to store in the cell state. This has two parts. First one is sigmoid layer, which is called the input get layer, which decides value we will update. Next, a 10H layer creates a vector of new candidate values that could be added to the state. In the next step, we will combine these two to create an update to the state in my power prediction model. It is now time to update the old state ct-1 into the new cell state ct. The previous steps already decided what to do, we just need to actually do it. We multiply the old state by f functions, forgetting the things we decided to forget earlier, and then we add. This is the new candidate values scaled by how much we decided to update each state value. So in this figure, we are updating new cell state. In the case of power prediction model, here we had actually dropped the information about the old record and add the new information as we decided in the previous steps. So in this figure, we are adding new record. Now final steps of LSTM algorithm. Finally, we need to decide what we are going to output. This output will be based on our cell state, but will be a filtered version. First, we run a sigmoid layer, which decides what parts of the cell state we are going to output. Then we put the cell state through 10H to push the values to be between -1 and 1 and multiply it by the output of the sigmoid gate so that we only output the parts we decided to. For the power prediction model example, since it just saw a subject or a record, it might want to output information relevant to a record in case that's what is coming next. For example, it might output whether the record is one or many so that we know what form a record should be conjugated into if that's what follows next. Now, my future plan, paper writing based on Objective 1 and implementation of Objective 2. This one is the sample data set. Now, thank you. Thanks a lot.